From San Francisco's Golden Gate Bridge, you drop a heavy rock. How many seconds does it take to hit the water? 77 meters below. We start by parsing the information given. We have a heavy rock. That means we can ignore air resistance. How many seconds does it take? That means it's asking for delta t. It's asking for the amount of time. 77 meters below. That's telling you that delta x displacement, or the distance traveled, is 77 meters, and actually it's negative 77 meters because it's below where we start. And this word drop is telling us that the initial velocity is equal to 0. And lastly, this is implied that we are on the planet Earth. The acceleration is equal to the acceleration due to gravity, or negative 9.8 meters per second squared. Now, the delta x and the acceleration both have negative signs on them because we're defining up to be the positive direction. So when we start with our equation here, our full equation, delta x is equal to v naught delta t plus 1/2 a delta t squared. Our v naught is 0, so we are left with delta x is equal to 1/2 a delta t squared. Now we are asked for, or we're trying to find, delta t. So we need to solve this equation for delta t. So let's multiply both sides by 2. That gets rid of the half on the right-hand side. Divide both sides by a. That gets rid of the a on the right-hand side. And take the square root of both sides. So we are left with delta t is equal to the square root of 2 delta x over a. Now we can go ahead and plug in our numbers. Square root of 2 times negative 77 meters divided by negative 9.8 meters per second squared. We have negative 77 on top, negative 9.8, so I'm just going to cross those out. So 2 times 77 meters divided by 9.8, 15.7, take the square root of that, 3.96. We have 2 sig figs, so 3.96 rounds to 4.0 seconds. A follow-up question to this is, when the rock hits the water 4 seconds after you drop it, how fast is it moving? For this, we're going to use our equation that delta v is equal to a times delta t. Remember, delta v is v minus the initial velocity. So v minus v naught is equal to a times delta t. And v, if we add v naught to both sides, we get v naught plus a times delta t. The initial velocity is 0, so we can just cross that out. We have a times delta t, negative 9.8 meters per second squared times 4.0 seconds. The seconds here cancels the squared second in the bottom of the acceleration. And we are left with negative 39.2 meters per second. We're going to round that to negative 39 meters per second because we have 2 sig figs. So the rock hits the water moving downwards at 39 meters per second.